give you about a little bit less than 15 minutes. Now, if you're at the Ag show yesterday, raise your hand. I think it was just Trevor Rand. All right, brother. You guys have an extra day since you guys were here. So yeah, so we had time to work on page 18 yesterday. So I'm going to give you less than 15 minutes. You can move around right now. After that time's up, and I'll put a little timer up just so I can keep track. Once the time's up, then we're going to go into notes today, and we'll finish the notes tomorrow. That's kind of how it's going to work. Does that make sense? So no new homework today. Homework is due at some point today, except for I guess the 3 people that were gone yesterday. So yeah, so, same thing. Okay. All right. We good to go? All right. Move around. Have lively conversations. Michaela, were you the one? Did I send a book home with you? So you had one at some point last week. Is that the same book that you have here? Okay. You want to grab that one real quick? Okay. The reason why I'm trying to keep track of where all my books are, they're slowly going missing. All right. Hey, if somebody borrowed a calculator from me yesterday, make sure they get it returned. I'm missing a calculator now. These are slowly leaving this classroom and not coming back. Okay. This assignment was assigned on Monday, I believe. Monday.
And then you
I was gonna come back yesterday, remember I wasn't here yesterday, so I was
yeah, so that's fine. You have an extra day to work on it, but that's something you should be working on. Plus, if you have not turned in page 8, I think that was the last page we had. That was last week's homework, last Thursday, Friday homework. Make sure you look for that one too. Okay, so yeah, so make sure you go online to the website, so you can do that here at school and stuff. On my website, hsmath.org. No, not the book, but the my actual homework and like the lessons. I actually record my lessons with the camera, so you can actually watch me teach it. So, and it's got the homework and everything on there. Plus JMC does too. So, but you can do that here at school. So.
For which one? For 22? What'd you get? Here. Let's just redo it together. Let's just redo it together. I could do them too.
Okay, and again, if you want to see the answer key, I have that. It's already made, so you can always. What? Look here.
We need to check those. Go see if it's 12. I could be right. It's number 23 or 22. No, 23.
How do you say that?
and it's 18.
I have to open up a couple pages there. It's the,
We're gonna have to redo that one.
Yeah, and then 76 is 3. Okay, I didn't get that for either one. It's cool.
because remember, you got to solve for the variable, and then you have to plug it back in.
I got 12 somehow. I got 3.3.
All right, because on those, I think, is that those last two, the 21 through 28?
Yeah.
Remember, you're adding 2 small pieces together
Uh-huh.
to equal the big piece, the whole thing.
Okay.
Gonna quit this class and going back to algebra.
Yeah, if you have any questions, please ask, especially if you're not getting a problem, you want to see it, that type of thing. Question?
Oh yeah.
21? Alright. Give me 21.
Mr. Ward.
Thank you.
What are we doing?
The whole thing. The whole thing.
Feels what?
Oh.
No.
I don't know where it was.
That'd be 360. No, 3.
Alright. Hey, what number is this? Okay. And they say in the instructions that y is in the middle.
1 and
y is in between x and z, right? Is that what they say? Okay. All right. Hey, if you don't know how to do like 21 through 28, or maybe 7 or 8, this is the kind of the idea. The first thing on 21, and I think it was like same with 7 and 8. They said that y is in the middle. They say like in the instructions, y is in between x and z. So that means if you draw a picture where x and z is at, y is somewhere in between it. That's how 21 through 28 works. So you have to draw like a mock picture. What I do is I take all that stuff and I label the picture. So like x, y is an 11. The yz here, this little stick is a 4c. And the whole thing is an 83. Okay, so that's what they gave you. So what you can do is you can add the two small pieces together, right? So 4c plus the 11, adding the two small ones, and that equals the whole stick, which is the 83. That's how you do 21 through 28. That's how you do, I think, 7 and 8. They're kind of the same idea, except for 7. 7's a weird one. So, but that's how 8 works. You add the two small pieces equals the big one. You should be able to solve by actually subtracting that over. So 83 minus the 11, which I believe is 72. And then dividing by 4, and I believe you get something like 18 or something like that. I don't know what the actual number is, so I think it's 18. Alright, so now that you have that, I think the secondary question, because they want you to solve for C. I think that's one of the parts in the instructions, like find the value for C. The second thing says find what yz is. That's a part of that's the second thing in the instruction. They say you need to find whatever the distance is for yz, like whatever that length of that stick is. It's common sense, but if you don't know, you just take this c and you plug it back into this, because that's what they want you to find, the yz part. So you're plugging the 18 in here, and if you take 4 times 18, right, because you got to plug the 18 back into the yz part, you get 72. So that's the number that you get. That's how you do 21 through 28. Every single one of those. That's how they work. Again, these are the two parts that they want you to find. Question? Yeah.
Why would you do that?
Alright, so you have
Okay, so no, 3 minus 11. 3 minus 11
plus
equals 72 and you divide by it.
It's definitely right.
I did every single one wrong.
Why? How?
Did you miss?
They were good.
And then subtract. Yeah, what, 2 and 3? Okay, so, hold on. 7 and 8. 7 and 8.
Oh, you mean right there?
I agree with 8. What do you get for? What do you get for 7?
Oh, you mean like
No.
Oh,
No.
I think you had to go.
How did you do that on that 7?
Oh, that's
Because
what
they give you these two things. They give you BD and BD. So this is the weird part. It's not like 8. They give you BD and BD. These two things are just actually 4x equal to 12. They give you 3 parts of quadratic. Just they said BD and 4x equals 12. They'll do the same thing.
Oh my gosh, Sadie, I know why.
But with 4. Yeah. And then you plug it back. Yeah, and that's the Okay, you got about 5 minutes left here. About 5 minutes.
I'm not gonna be done in 5 minutes.
It's still the wrong answer. It's still, yeah, I know, that's kind of confusing, right?
I need help on.
So, it's still gonna be the wrong answer. Okay, so we added the variables, okay?
So after this, you get your couple
So it's 12A.
I would do this, so that I write that.
No, you plug it back into the YZ part.
To the C Hypotenuse. But look, it'll still be.
They want you to find what the value of YZ is.
So the actual answer is 72. But do we have to separate it?
Yes. They want it both.
So look at 7 equals 5 and 12 equals 6 and 4. Well then don't I divide?
Subtract the 6A over.
And then that's 6A. No.
So YZ equals 72.
Bam.
4.
Yeah, those two together get 6. Okay. You get the before you add it over. And you're gonna get that one.
It's like 0.2.
I didn't. I was trying to. A equals 4. Did I do that right? Difference. And the other guy. It's fine. What number are you doing now, Jane? Is that right though? Divide by 6. Divide by 6.
Where do you get the 24 from? I thought it was. Oh, no, you got it.
Is that right? But now what? I plugged it into both sides now?
Plug it in the YZ. I think that's the one they want.
Is the Y is the only one? That's how you get 20. Oh man. So you always have to plug it into the Y is equal.
Yeah, on the
That's it. You're gonna be your answer every time you go into the other answer. No, she's got it. She's 20. So that's the only part you need. Surprise. Yeah, I have to read all the other ones now. Wait, did we say that?
You
Yeah.
have two chapters.
Why? You said I didn't see that part. Do you need both answers or not? Like,
Both. They want the C and then they want the YZ answer.
oh, that's did. Oh, so C would equal 4. Get away.
Note versus from back.
Yeah. Did she use it?
Can I use my phone as calculator?
No. You use one of those. Okay, I got less than a minute here. Try to get back into the normal seats where you're at. Got it, less than a minute. There it is. Alright, try to get to your back to your normal seat. Full 5 minutes. those who are the select people that were gone yesterday, I understand you get some extra time to work on that. Today, remember I said that this assignment's due at some point today. Some point. So if you have study halls or whatnot, turn in later. I don't care if you turn in after school, but get it done today. I'll be here after school for a while because we don't have bus time for volleyball for a while, so I'll be here after school if you have any questions. So make sure if you still have stuff to work on, just take a picture of it. Or if you don't have a smartphone, have somebody else take a picture of it and email it to you. So that's just kind of how it works. Okay, until we get those books. No word on the book shipment yet on whether we're getting those geometry books. They were supposed to come in yesterday. Haven't got any boxes yet. So, all right, today we are going to go on to section 1-3, talking about the number line Cartesian coordinate system. I believe we introed this yesterday. And again, if you don't know, you can always go to my website to watch that in case you're gone, because I know some of you for ag were gone. Yesterday was just kind of a work day. We introed it the last 5 minutes of class, but this is the website. If you want to watch any of those lessons, watch how to do something, that's the website. It's HS, like high school, hsmath.org. That's mine. You'll know it, and then you can click on geometry on there, and you can watch the videos. So, all right. So, let's walk through the number line and the Cartesian coordinate system, because we need to make sure that we know how to actually find distance with these two objects. I hinted at how to do Cartesian coordinate system yesterday, but we never went in depth into why and how to actually use it, because it's brand new. So we got some vocab terms, we're going to talk about history, and then we'll get to these actual formulas of this. Again, homework due today for those who were actually here yesterday. So, all right, so let's walk through this. So number line. Most people know the number line is pretty straightforward. Number line is just a line, so it has arrows on both sides. It just represents numbers in order. The big thing about number lines is that you guys have been like programmed since elementary school to see a number line a very, very specific way. There's no real purpose for the number line other than just putting numbers in order. It actually doesn't matter which direction you go with positive or negative, and that's the part that blows people's minds. That when most people learn in elementary school, this is how they learn it. Correct? Like that's how you learn it. Didn't have to be. You could have the positives go the other direction. It's just a line that puts numbers in order. That's all it does. So that's a big deal. It is a solid line. There's no breaks in it, even though I have dashes. There is still numbers in between. There's decimals, fractions, irrational numbers. That's something we're going to talk about today, a little bit of history of mathematics. But it is a solid number line. For every micro dot that's on that number line, there is a number associated with that specific location. So that's something that a lot of people don't realize. They always just think it's whole numbers. It's decimals and fractions too. Okay, now define distance on it. Define distance between any points. Doesn't matter which points you pick. I'll pick -2 and 1. Okay, define that stick. Define how long that segment is from -2 to 1. What you do is we have this little basic formula for distance if it's on a number line. You subtract the two numbers in any order you want. XY, YX, it doesn't matter. It doesn't matter the two numbers there. -2 or 1, you can switch them. You have to subtract them. Okay, so, and then once you do that, then you have to put absolute value bars around it. The reason why is I want to guarantee that your answer is positive in the end. That's what I want to guarantee. That's why it doesn't matter the order that you subtract, because when you do the absolute value, it cancels out the negative sign anyway. That's the idea. So, for instance, we have the -2 and the 1. Which one would you like me to write first, -2 or 1?
-2.
-2, okay. So we're going to write it like that. So -2 minus the 1. Put in absolute value bars. I'm taking the first number, I'm subtracting the second number. That's how you find the distance. Now, most people can count this by hand. How many bunny leaps are there? How many gaps are in there between the hash marks? 3. That's your answer. Like, most people can count it with their hands. It's pretty easy. But this is the actual formula that shows why it's 3, okay, other than just counting. So, -2 minus 1 more is -3. And then the absolute value of -3 is 3. That's the distance. That's the distance from -2 up to the number 1. That's the idea. Now, and again, why it's the number 3 is absolute value just gives you positive numbers out of it. In fact, the definition of absolute value is the distance from 0 on a number line, the distance from 0 to this number that's in the actual brackets. So the distance to get from 0 to this number actually takes you 3 steps to get there. That's why the answer is 3. That's how smartphones, Fitbits, any like physical tracker works. It doesn't matter if you walk forwards or backwards. It's giving you a distance that you're walking. That's actually how it's doing. It's doing an absolute value of the difference. Okay. All right. Now, and again, I hinted at it doesn't matter the order you subtracted those two numbers, the two outside numbers, your endpoints. So if I went 1 minus the negative 2, because I'm subtracting the two numbers, and I'm taking the 1 minus the other number, what happens to the two negative signs here? Yeah, right. That's called the property of opposites, or the definition of subtraction, that the two negatives, negative, would actually cancel with my plus, and now you have 1 plus 2, which is 3, and you're taking the absolute value of it, which is still the same answer. That's why I said it doesn't matter the order you subtract, you're going to get the same distance anyway. It just depends on how comfortable you are with negative numbers. All right, any questions with number line stuff? I think most people can do that in their sleep. It's pretty straightforward. I think you've learned that in maybe 7th to 8th grade year, probably, in general math, pre-algebra kind of thing. Okay, the new topic today, though, the one that I really want to hammer down, is this Cartesian coordinate system. That system's tough. Like, it's hard to look at. Okay, so let's take a look at that. So let's do a couple vocab terms with this first, and then we'll get to the actual difficult math here. Okay, this is a Cartesian coordinate system made by a French mathematician, René Descartes, in the 17th century. It's very, very old. It's just two number lines. That's what you need to realize. Most people, they see it, they like get a panic attack because they don't do any algebra. It's just number lines. It's just the thing I just drew. That's all it is. They just put two of them on top of each other. So this spot in the middle is the origin. It's the middle, it's where the crosshairs meet. It's the same over here. The name of 0 on a number line is still called the origin. It's the same name because it's just literally two number lines. So I have positive numbers going this way because it is a number line. So 1, 2, 3, and 4. Number line going this way. 3, -2, -1, and yes, there is decimals in between all of those. And then going up, this is now the second number line. Going up, I still have a number line going that way. So this is 3, 2, 1. And then going down, I still have negative numbers. Okay, does everyone see that it is just two number lines? Now, what I explained yesterday, we explained how to get to any location on this object, right? That we have two axes, right? Two number lines. There's the x-axis and the y-axis. How this works, you have to put coordinates, that's what I'm calling them, coordinates. You have to put coordinates in what we call an ordered pair. What I mean by ordered pair, they're literally written in alphabetical order. So, when you look at the two axes, what are the two axes written in alphabetical order? So, what letter comes first, X or Y? In the alphabet. X, right? That you learn alphabet since preschool, right? X comes before Y. That's why they called it an ordered pair. It's literally written in alphabetical order. That's how I remember it. So the X number comes first, the Y number comes second. And I think one of the examples I did yesterday was like 3, 2 or something like that. How you do this, like the most easiest way that I explain it, so you don't have to remember like alphabetical order if you go right or left or up or down first. It's just imagine you're walking into a hotel. This is a hotel. This is the main lobby of the hotel. So you walk in right into the front doors of the lobby, right at the origin. You have to pick an elevator in your hotel. So I'm picking the third elevator, because you have to pick the elevator first, then you can go up and down in it. That's how it works. So once I pick the third elevator, because that's the first number I see, now I can go up to the second floor. There. There's your point that goes with, I'll call it point A. That's how ordered pairs work. You can get to any location on an actual coordinate system. Now what a lot of people don't realize is we still use the coordinate system today, not just for algebra class. Like how many people in here, raise your hand if you have a smartphone. Like you have an Android or an iPhone. Those objects use the coordinate system. That's how they map pixels on the screen. That's how they know when you touch the screen where you're touching. Because your finger is hitting a certain pixel, which is associated with the grid. That's why if any of you are really familiar with like Photoshop, that really like high-end photographics program for a Mac or a PC, that program, you can actually see in the corner when you're actually working in Photoshop and you're messing with a picture. Here's your lovely picture. And you're detailing it, you're fixing it up, right? Down in the corner, they have actual coordinates being shown across your MacBook. Okay, what those are the pixels where your cursor is currently sitting. That's literally what it is. Because there's a certain amount of pixels that are on your MacBook screen or your Chromebook screen. Okay? It depends on how high definition your screen actually is. And it tells you what pixel number you're at. So you can get like super precise on what pixels you want to fix. It's still this system. It's literally an x-axis number and a y-axis number. That's how GPS works around the globe. They just took this grid system, the Cartesian coordinate system, and wrapped it around the globe. That's what they did. So when you look at, an actual picture of, or if you look at like Google Earth, I love Google Earth, but when you look at it, they give you, so here's your globe. They give you the horizontal number first. Horizontal, right? That's x-axis number. They're giving you that number first. That is called a latitude number. They give you that first. Now latitude is it's a horizontal number. It's compared to the equator. So that's these numbers. It's the horizontal numbers. So what they do is the equator is 0 degrees. Then they count up till they get to the North Pole, and that's 90 degrees. That's a perfect like L. And so, we're at about 33 degrees north. So that's a horizontal number. You're giving me the x-axis number, the horizontal first. Then you give me the second number, which is the vertical number, the y-axis number. The vertical number going up and down is the longitude. And for us, it's like 93 degrees. 93 degrees west. And that's based not on the equator, but it's based on what they call the prime meridian. Prime meridian goes through like Greenwich, England. I believe they used to call it like the Rose Line. It used to go right through the middle of like Paris, France. If you're really big into history, a really like good book, even though it's fiction, is reading Dan Brown, the author. Does a really nice job of like incorporating some history facts into his books. Some anyway, but he talks about like the history of like longitude, latitude numbers stuff. But the idea here is that's how a globe works. That's how you get like how your phone leads you, and how you can use your GPS to actually lead you somewhere. That's how Pokemon Go works. And it's trying to lead you to your Pokemon. I mean, it's literally just a grid. It's giving you an x-axis number and a y-axis number. Okay, does that make sense? Like you're still using it today, even though it's literally, this thing was made in the 17th century, just so it's easy to use. Military uses it all the time. They have quadrants. Now this is the first quadrant, second quadrant, third, and fourth. They go counterclockwise. That's how quadrant systems work. Okay. Most people get that wrong. If you're ever from like a foreign country, like if you come from like Italy or France or something like that, or you visit there, or you study abroad, they teach it backwards. They actually teach it clockwise, which I find funny because I've had foreign exchange students always disagree with me. Well, it's just how their country teaches them. U.S. teaches it like this, and there's a reason why we teach the quadrants in a backwards order. It's because of the thing we're going to learn not tomorrow, Monday. We'll learn Monday, and I'll explain that. Okay, all right. So that's a coordinate system. That's a crash course into it. That's a little bit of the history about that. All right, now let's talk about what we're going to use this for. Why do we need the coordinate system? We need it to find distance on a coordinate system. So, for instance, if I pick this spot right here, I'll call this B, and B is -1, comma -1. So it's over -1, down -1. So those are my two coordinates. We can find distance between A and B. Okay, now here's the bad part. You can't count with your fingers. Okay, it's not like the number line. Like this is silly. I can just count. That's 1, 2, 3 leaps to get there. Right, that's easy. I don't even need the formula. When you do on a coordinate plane like that, now you have to use the formula to to find what is the distance from A to B. It's not a simple number, because the minute you go diagonal, now the numbers are not nice whole numbers anymore. It's not. It's some weird number in between. That's the idea. Okay? Now to do this, to actually figure out what is the distance from A to B, we have to rely on one simple property in geometry. And I'm going to put up the name up here. I'm going to see how many people recognize it. There's one simple property, and then I'll get to the actual formula here. The property that explains how to find distance from A to B is this property. Called the Pythagorean Theorem. How many people have actually heard of that theorem before? Know the name? Okay, interesting. All right, maybe you're just too shy. All right, so the Pythagorean Theorem. That theorem is this. A squared plus B squared equals C squared. How many people recognize that now? Okay, that's what I thought. Maybe people didn't know the name, but they know the actual formula itself. This formula applies to a triangle. That's what it's applied for. So in fact, let me write that little down, that little note down. It applies to a triangle. It's part of basic trigonometry. If you don't know what trigonometry is, it's the study of triangles. Not just any triangle, one specific one. The triangle that we're going to apply this to is a right triangle. Now, what do we know about right triangles? What do you know about the word right? Perfect. It's a 90-degree triangle. That's what the word right means. 90 degrees. There has to be one 90-degree angle in that triangle. That means it has to make a perfect L shape. Well, that's what you have on your picture if you can see it. I literally have a right triangle either going up or going to the side. I'm going to go to the side because this is easier to look at. Does everyone see that I have a right triangle now? And the whole goal here is to find this distance. That's what we want to find. The blue line. If you're colorblind, I'm really sorry. It's the line I have the arrow pointing to. Okay, does everyone understand what we're using this for? Okay, now, what most people don't understand is like, okay, they see this, fair enough, but how does this apply to a triangle? Like, what numbers do you use? That's the goofy part. Okay, where do I put things? How does this work? Okay, so this is the easiest way I can explain it. What you do is that the A and B number, these two numbers, because these are A and B are literally just a digit, it's a number. These numbers come from this line and that line, the line going up and down. So the easiest way I can explain to you is that the A and B number are literally the walls of the triangle that are touching the 90-degree little box in that corner. Okay, so the walls that touch the little box, the 90-degree, the little L shape, those are the two numbers that go here and here. That's what it's used for. So, let's associate some numbers here. So, I want this wall. How long is this wall? That's what I want to know. So, how long it is, it's how many gaps there are when you actually like associate where the numbers are. How many gaps are there? 4. That's the length of that wall. It's literally 4 pieces long. Okay? So that could be your A number. So I'm going to go 4 squared. So I'm plugging the 4. Okay, now going up and down. How many pieces are going up? There's 3, right? So that's your B number. There's 3 going up. How I'm doing that is I'm using like the numbers from the y-axis and x-axis and just transferring those marks down. Because normally when you look at a grid system, they have all those crazy lines going everywhere, so you can actually see how many spots you're actually traveling. And or the easiest way to do is if you need to know how long this stick is, you have 3 and a -1. You could do the simple like number line thing where you just subtract these two numbers from each other. 3 minus a -1, that's literally 4. 2 minus a -1, because that's the height. So that's 2 for the height. It's a -1 for the height. And you subtract and you get 3. That's another way you can do it. But now that you have those, I can plug those numbers in, and whatever I solve here, that's going to equal the blue wall, which I don't even know, that's my unknown, squared. The one that I have the arrow pointing to, that's the wall I don't know. That's the wall I'm trying to find. And so I'm going to use like an X, because I don't have any variable. If you want to use like, if you want to leave it like a letter C, I'm fine with that. It's whatever you're comfortable with. Some people like to leave the C there so it makes sense to them. Okay, now what these are called, because I do want to give them a name, so I'm not just always calling them like the C wall and the other two walls, because I know that seems weird. This blue wall here actually has a name. It is called the hypotenuse. It is the hypotenuse. That is the blue wall. It's the diagonal wall. The other two walls that are making the L shape, these two walls are called the legs. These are the legs of the right triangle. They can be different numbers, it's fine. Leg 1, leg 2, whatever you want to call it. The hypotenuse is technically the bigger wall out of the three. It should always be that way for a right triangle. But I can tell you right now that to find the hypotenuse, you have to use this formula. It's the only way you can find it, that one wall. Okay, so let's go through the math here so you can actually see how to solve this, so I can explain it to you, so you know what we're looking for. Okay, so let's do some of the basic little math, computational stuff. 4 squared. 16, right? But let's talk about y. What does a square mean?
You times 4 by itself.
Yeah, you take 4 times itself. It literally is telling you that you have 2 4s side by side being multiplied. So that's where we get the 16 from. You know, it's 4 times 4. It's not 4 times 2. Don't make that silly mistake. It's 4 times itself. There's 2 of the 4s. Okay? And then same thing over here. There's 2 of the 3s. And that is 9. Okay? And then the other side, I don't even know that. That's just a c squared, whatever you want to call it. You can call it x squared on here. It's your variable. It's the thing I don't know. It's the wall I'm trying to find, the hypotenuse. Okay, we add these two together. If you add 16 and 9 together, you get the number 25. And now, I only have one more step to solve. And no, you do not divide by 2. That's silly, you don't do that. This is a power, right? The goal is to get the c by itself. So what we have to do is we have to do the complete opposite of a power of 2. Anyone know what the opposite of like a square is? Like the power of 2? Anyone know what the inverse operation is?
Square root.
Yeah, square root. That's actually why they call it a square root. It's literally the opposite of a square. This is a square, so when you drag the little 2 to the other side, you do a square root to the other side. That's how you solve. That's how you find the distance. That number, the square root of 25, is literally the distance. Now, that's something we need to explain. What is this? Okay? Because some of you may have seen it, some of you might be proficient at it, some of you are probably looking at it and going, I've never seen that in my life. I have no idea how to solve that. So, this symbol, okay, even though we call it a square root, because that is the correct term, this symbol is actually called a radical sign. Okay, it looks like a division sign with a little tail on it. Okay, it is called the radical sign. The number on the inside that we put in here, in our case it's a 25 down there, but the number on the inside, whatever this number tends to be, this number is called the radicand. That's the number you're trying to find the square root of. Okay, and then, what a lot of people don't know, there is secretly a number written in the little tail. The number in the tail is actually called an index number. Called an index number. Now for us, what do you think the number is written in the tail? Even though it's not written there, what do you think it is? It's a 2. There's literally a 2 there. It's secretly written in there. It's a 2. Why it's a 2 is because what power did I bring over? A 2. That's why there's a 2 sitting in there. That's literally what it comes from. Alright, now, most people are going, okay, Mr. Ward, fine, you're getting a little too excited. Calm it down. How do we solve it? That's the idea. So, why I found this important, why did I want to show you the index number, is because the index number explains what you're doing. It explains how to solve it. So what I mean by that is the index number tells you everything. This number is super important. It's telling you that you need to find two numbers that multiply together to give you this. So you're going to take a number times itself, two numbers multiply together, that will give you the number on the inside. Okay, what number multiplies on itself to give you 25? That's your answer. That's the distance on that stick. Okay, homework. What I'm gonna do is if you have not got the homework done today, bring it tomorrow. I'll be fine. Make sense? I'll give you an extra day if you need to work on it.